Hello students. So in today's class we are going to discuss about the limiting or balanced or maximum depth of neutral axis. In the previous class we discussed about the depth of neutral axis. Now we are finding or determining the maximum limit for this depth of neutral axis. So put side heading maximum or critical or limiting or balanced depth of neutral axis, that we denotes with XU maximum. Before we are going to find out this maximum depth of neutral axis, for understanding purpose I am drawing the cross section of the beam. So this cross section of the beam having a neutral axis, and there is a tension reinforcement in the tension zone, that is nothing but area of steel, and also the width of cross section of the beam having, this is width and this is effective depth, that denotes with small d. And we know already in the previous class there is a strain distribution having a shape linear, and compressive strain, the ultimate compressive strain, that is 0.0035, and coming to in the tension zone the tensile strain should not be less than 0.002 plus 0.87 Fy divides with ES. In 2012 gate there is a 1 mark bit, that is in the tension zone what is the tensile strain, that is 0.002 plus 0.87 Fy is nothing but yield strength of steel, that is grade of steel, and ES Young's modulus of the steel. Irrespective of the grade of steel, our Young's modulus of the steel is 2 into 10 to the power of 5 Newton per mm square. So to determine the XU maximum, so first of all I am considering this is my maximum depth of neutral axis, XU maximum. So I know this depth, I know this depth, I want this depth. How to determine this depth? Total minus this part, then I will get this one, is nothing but D minus XU maximum. This is D minus XU maximum. By applying similar triangles, now I will determine this XU maximum. Is nothing but for this much of depth my strain is this much. For this much of depth, this is my strain. So now XU maximum equals to 0.0035 and D minus XU maximum equals to 0.002 plus 0.87 Fy divides with Young's modulus of the steel. Okay, so now I am applying similar triangle. This one is numerator, I am taking is nothing but D minus XU maximum divides with XU maximum equals to, what is the D minus XU maximum value? 0.002 plus 0.87 Fy by Young's modulus of the steel. It divides with this strain, that is 0.0035. Now taking LCM here, D by XU maximum minus XU maximum by XU maximum. XU maximum by XU maximum is equals to 1. So now D by XU maximum minus 1 equals to 0.002 plus 0.87 Fy divides with ES, divides with 0.0035. Now what I am doing is this minus 1 I am taking into this side, then it is becomes plus 1. Okay. So now d by xu maximum equals to 1 plus enter this value, that is 0.002 plus 0.87 Fy divided by Es divides with 0.0035. Now what I am doing is I will apply LCM for this one also. Then what happens? If you are taking LCM for this, then 0.0035 into 1, 0.0035 plus this portion overall divides with 0.0035. So I am erasing this portion. Now d by xu maximum equals to then 0.0035 plus 0.002 plus 0.87 Fy divides with Young's modulus of steel divides with 0.0035. Now ulta, that is I need xu maximum by d equals to, now it is also reverse, 0.0035 divides with 0.0035 plus 0.002 plus 0.87 into Fy divided by Es. Carefully observe, this is the final derivation we determined by applying these similar triangles. If you see, this maximum depth of neutral axis is depends on which one? Grade of steel. There is a 1 mark bit. Maximum depth of neutral axis is a dependent of grade of steel. It is a independent of grade of concrete. Here there is no concrete, is nothing but FCK we have used anywhere. No, there is a competitive bit. Maximum depth of neutral axis is a dependent of dash. So one is depending upon grade of steel, grade of concrete, both none. So what is our answer? Depends on grade of steel. So now what you will do? You substitute the values. This is xu maximum you want. This d is not diameter, it is the effective depth of the beam, and these are all numerical values. This is grade of steel. We are having 3 types of grades normally. One is Fe 250, Fe 415, Fe 500. So different grades of steel, different values of xu maximum we will find out. This is constant, that is 2 into 10 to the power of 5 Newton per mm square. So after substituting these values, the final value of maximum depth of neutral axis is for each grade of steel. So now what I am doing is I am substituting now. For Fe 250 grade steel means Fy equals to 250. Now I am substituting. Then what about xu maximum by d? Xu maximum directly I am substituting value. It is 0.53. Your after substituting you will get the value is maximum depth of neutral axis is 0.53. For example, if you substitute Fe 415 here in the place of Fy, then your value of xu maximum by d is 0.48, decreasing. If the grade is increasing, your value is decreasing. Next you substitute for 500 the same here, then your xu maximum is by d is 0.46. So this is the final values of your maximum depth of neutral axis. So put it in dabba. Very, very important. There is no need of every time you don't want to derive all these things. Directly you can remember for FE 250 grade, what is the XU maximum value is 0.53 times D. Sir, how to remember this? Without remembrance, can we register? Yes. From page number 70 of IS 456 2000, if you open, directly these values are available. For 250 grade, this is 0.53 and 0.48 for 415 and 0.46 for 500. Sir, okay, very nice. You told that depth of neutral axis and also maximum depth of neutral axis. What is the purpose of determining this depth of neutral axis and maximum depth of neutral axis? So, if we want to know these things, we should go for flashback. So, when we are going into the flashback, first of all, we have to learn 3 types of sections. That is, put side heading, types of RCC beam sections. One is under reinforced section, second one is balanced section, third one is over reinforced section. Before we are going into the technical, I will give you one example for easy understanding purpose. I am considering our outer ring road. So what is the maximum speed limit of outer ring road? So there is a 100 kmph. So my maximum speed limit on ORR when I am going to drive, that is 100 kmph. This is the maximum limit. I do not cross this limit. If I cross this limit, what happens? There is a danger. Okay, so if I am going to this speed or always be less is so better. That is we know. So this is the maximum speed. Now I am considering this as XU maximum. This is my XU maximum. Okay, so this is the maximum speed limit. Now I am driving with 80 kmph. Now I am going with 80 kmph speed. So then what happens? It is less than the maximum speed or not? Yes. If I am going less than the maximum speed, this is I am considering XU. So this is maximum, this is less than that. So it is safe or not? Because the maximum is 100, I am going with less than the maximum, then I am safe or not? So I am safe because I am less than the limit. So this is comes under reinforced section. When you are not crossing, when you are always be less than the maximum limit, then the type of section is called under, in the name itself, under reinforced section. So now what I am doing is I am increasing my speed and now I am going with 100 kmph. So what speed I am going now? 100. My maximum speed is also 100. I am driving with 100 speed. That is critical balancing. So I am going with maximum limit edge. So XU maximum is 100. My XU is also 100. Now what happens? XU equals to XU maximum. Both are balanced. Both are maximum. Now this type of sections are comes under when both the values are same, then this type of section comes under balanced section. Okay. Now what I am doing is, now I am going with 120 kmph. I am increasing my speed. It is maximum is 100, but I increased my speed to 120 kmph. Now what happens? Over speed, I am crossing my limit. Then I am in trouble or not? Obviously I am in trouble. So this is XU. Is nothing but, now what happens? XU maximum is more or XU is more? XU is more, then XU is more than XU maximum. It is comes under over speed, is nothing but over reinforced section. So please keep in mind, for understanding purpose I am using this example. I think you might be understood based on this example. So now what you should do? You should go with this speed or you will come back. You do not cross this limit. You always be within the limit or maximum limit. So please keep in mind this example and also this dialogue also, why I am telling do not cross the maximum limit. If you are crossing the limit, once again you will come back to its maximum. Please keep in mind this point, especially this point you should keep in mind. I will apply this point somewhere in the middle. Okay. Now I am going with a technical derivation how this will happen under reinforced section and balanced section or over reinforced section. So under reinforced section, once again I will apply this cross section. This is the tension steel. So now what happens is, this is my maximum depth of neutral axis, that is XU maximum. Under reinforced is nothing but under, when required is more but you are taking less than the required amount of the steel, then that is called under reinforced. For example, you need 100 mm square of the steel you need, but you are taking less than the required amount, then the type what it comes under? Under. So when you are considering less than the required, what happens? When there is a external loads are coming on that section, who will be critical? Steel will be critical. Why steel will be critical? Because it is not providing whatever the required, you are not providing that much of sufficient, then that is the weakest point. So the stresses first develops on steel, so that steel will reach its first permissible stress. So what happens is, steel is a ductile material. Because of their ductilinity, you have seen in strength of material slab, when you are testing tensile strength of mild steel bar, what happens? It will take the load and it will strain and it will fail. It means it will elongate it and then it will fail. Is nothing but what happened is, it will give lot of warnings. It is doesn't sudden failure. It will give lot of warnings, then it will fail. It is good symptom or not? Obviously, because whenever before failuring the structure, we should know whether the structure is stable or not, and also we can identify, array this structure will not be more, so we can vacate this structure. Even the government officials also visit our structures and they will tell you that, so please vacate this structure may be fail any moment, so please vacate. So it doesn't mean that there is a warning. If steel will reach its permissible value, there is no problem, because steel is a ductile material. It will give warning so that we have a time to escape from that structure. It is nothing but not in a single day or single minute. It will take time, but just I am telling that we can understand this structure will be collapsed maybe few days or few months. Okay. So that is nothing but, who is under stress first? Steel will under where is steel? This is the steel portion. If steel is having more stress, then what happens is, this is the situation. this is all under stress, then your XU is this portion. Now XU maximum is more or XU is more? XU maximum is more, XU is less, because steel is under stress, more steel under stress, then your XU is less than XU maximum. So this type of sections are practically useful whenever you are going to design any structure. You always prefer this under reinforced sections. This is very good for designing purpose. So next one is balanced section. So please understand, in the name itself it is saying balanced sections. So again I am drawing this strain distribution. In the balanced, what I am telling? XU equals to XU maximum is nothing but both stress in concrete and stress in steel, both will reach its permissible value simultaneously, is nothing but at a time it will reach its maximum point or permissible value. Is nothing but the stress developed in concrete and stress developed in steel, both will reach its maximum permissible value at the same time, then that type of section is called balanced section. In this case, your neutral axis depth and maximum depth of neutral axis both are same. Okay. So the next one is over reinforced section. Same, over reinforced, in the name itself it is saying over reinforce. Over reinforce means you are providing more than the required amount, then what happens? Steel is more, obviously concrete will be less or not. So if the concrete will be less, then that is the weakest point. When the external loads are acting, the stresses will be developed in steel or concrete. Concrete will develop first stresses. So because of the concrete will take the stress, concrete is a brittle material. Because of that brittle nature, what will happen? It will take the load and it will suddenly fails, like chalk piece. What chalk piece will do? It will ductile or it will sudden fails? Sudden fails. Even concrete is also like a brittle material. It will take the load and it will break suddenly. Is it correct? No. There is no warnings. It is a sudden failure. So this sudden failure should be avoidable when you are designing any structure. Is nothing but whenever you are designing, so over reinforced sections are avoidable. As for IS 456, over reinforced sections are avoidable because concrete is under stress first. Concrete will reach its permissible value first. This is a negative symptom. So avoid over reinforced sections. Is nothing but concrete is under stress. What happens? This is your XU, because concrete is under stress more, but your maximum depth of neutral axis is this one. So what happens? Your XU is more than XU maximum. This is not correct. Sir, if it will occur, what happens? Previously I told, when you are crossing your speed limit, what you will do? Immediately you will come back to maximum value. So similarly, in the problem, whenever you will get this over reinforced section, you avoid this over reinforced section, then what we will do, sir? So what you will do? You will come back to your maximum limit now. Same way here also, you will design that beam as a balanced section. So what you will do? You don't want to consider this XU value. You should consider in the place of XU maximum is nothing but design it for balanced section. Okay. So for that only I told you to remember. So whenever this over reinforced sections are getting in the problem, you don't design for over reinforced section. You should design it like a balanced section. So I think you might be understand why we are determining this XU and XU maximum. So to know the whether it is under reinforced section or balanced section or over reinforced section, to get that information you should know first of all this depth of neutral axis as well as maximum depth of neutral axis. So this is about whenever any problem you will get it, first step is given data. So the step 1, given data. So after this step 1, what you will do? In the step 2, find out depth of neutral axis, that is XU. You know already in page number 96 of IS 456, it is directly available XU. So every time you don't want to see this IS 456 2000, you should remember, because this code book is not only useful for the examination point of view, even practically when you are going to design any structure, you have to follow this IS 456 2000 until otherwise revised for any year. So directly should remember. How to remember? I can say XU equals to 0.87 Fy AST divides with 0.36 FCK into B. So like that you should remember every time open page, this is not correct. So next one is in the step 3. So I think you might be know, after getting XU, what is next you have to find out? Maximum depth of neutral axis. Obviously. Why? Because if you are knowing these two values, then you can find out whether this is comes under comparison. XU is less than XU maximum, or XU equals to XU maximum, or XU is more than XU maximum. So based on that you will find out these type of sections. So this is about the types of RCC beam sections. So next, after finding this whether we are having this, what is that, under reinforced or over reinforced or balanced section, next what we should do? What we should do? We should find out the moment of resistance of the section. So it is interlinked. Next one, we should find out moment of resistance of the section. In the previous class already we discussed about this moment of resistance of the section, that is MU. Now please put side heading ultimate moment of resistance. That is MU. What is moment of resistance? When there is a external load is acting, what the member is doing, it will offer some resistance. So it will try to twist like this, but my hand is try to avoid this, what is that, twisting. It is nothing but there is a resistance is offering. So how much this resistance is offered by your member? You should determine, because based on the external load, how much the moment of resistance offering my member, that is very important. Already we know MU equals to, in the previous class, this is also available in page number 96 of IS 456. 0 point is nothing but already in the previous class, total compression into lever arm, or total tensile force into lever arm. So now compressive force I am applying, anything you can use it, FCK into BXU, this is my total compressive force, into what is lever arm, D minus 0.42 XU. This is my moment of resistance of section. Now what I am doing is, I want to find out the, here also moment of resistance also, this is moment of resistance. I want limiting moment of resistance like XU maximum. I want here maximum moment of resistance or limiting moment of resistance. Now I want limiting moment of resistance. What I should do? limiting you want, what you should do? Apply common sense. In the place of xu, what you will apply? Xu maximum. So you want maximum, you will use maximum value only. So what I should do? Mu limit equals to 0.36, other values don't change, b into, in the place of xu maximum into d minus 0.42 xu maximum. Okay. So what I am doing is, in the next step, I am taking d as outside. If I am taking d outside, this is 0.36 fck into b into d into xu maximum 1 minus 0.42 into xu maximum by d. So mu limit equals to 0.36 fck into b into d into xu maximum into 1 minus 0.42 xu maximum by d. So already we know the xu maximum by d value. So similarly here also I need xu maximum by d. If I want here also by d, what I should do? Multiply and divide with d. Then I will get xu maximum by d format. So please recollect, xu maximum by d we find out already for different grades of steel. So d into d, it becomes now d square. So what happens? Their limiting moment of resistance is also depending upon grade of steel, because if you substitute for 250 grade 0.53, you will get the moment of ultimate limiting moment of resistance 1 value. If you substitute for 0.48, you will get different value. If you substitute 0.46, you will get different value. So please substitute. Finally I will tell you what are the limiting moment of resistance for different grades of steels. That is, mu limit equals to 0.148 fck into bd square. This is for Fe 250 grade, and 0.138 fck bd square for Fe 415. Substitute. You will substitute here xu maximum by d values for this grade and this grade, and next 0.132 or 33, no problem, bd square for Fe 500 grade steel is nothing but your moment of resistance, limiting moment of resistance is also based on grade of steel. So put it in dabba. So every time you don't want to derive everything, so some of the things you should keep in mind, you should register in mind. So directly, this is the grade of concrete, width of the beam, effective depth of the beam. You will substitute, then you will get the maximum or limiting moment of resistance. Even you can compare with mu limit also. Once we are solving the problems, how it will be useful, then you can understand. So in the today's class, we are determining maximum depth of neutral axis and maximum or limiting moment of resistance. Okay. So this is about the moment of resistance. Just last, before we are going to wind up the class, I will tell you there is a singly reinforced beam and doubly reinforced beam. Very important in the university examination point of view. These two things are very important. So please keep in mind. Just 5 minutes. One is singly reinforced section, or beam, singly reinforced beam, or doubly reinforced section or beam. So how to do it is, again I am taking this example. This is one cross section, one dabba. This is another cross section, another dabba. This is my neutral axis. Singly reinforced, in the name itself is saying singly reinforced, means I am providing my reinforcement in only one zone, that is tension zone, because tension will develop below the neutral axis. So who will take care tension? Steel will take care tension. So this type of section is called singly reinforced sections. When you are providing reinforcement doubly in both the directions, then that section is called doubly reinforced sections. Sir, when we will use singly reinforced section and when we will use doubly reinforced section? See, practically singly reinforced sections are not possible. Why? Because if you want to provide the stirrups, so how to tie the stirrups means it is not possible, because you are having reinforcement in tension zone, but your stirrup will be like this. Then where is the bond? So there is no bond. So what happens? Without bond, there is no strength. So practically singly reinforced sections are not that much of useful. Even singly reinforced we are talking, but we will provide minimum number of bars, that is tie bars we will use for the tying of the stirrups. Okay, but even a university examination also, compared to singly reinforced, doubly reinforced, there is a 99.99% chances are there. Put it in triple star. In every paper almost you can see there is a problem from doubly reinforced, there is a 1 mark or 2 mark question from singly reinforced. Sir, when we will go for this doubly reinforced, you are saying that in the previous class, above the neutral axis completely compression means concrete will take care, below the neutral axis there is a tension steel will take care, but you are providing in the compression zone also. In nothing but when the depth of the beam you are restricting, then what happens is even in the compression zone some portion of tension will develop. So minimum 50% of the bars we should provide in the compression zone also. Normally depth of the beam, see some of the beams we are having more depth, it will occupy more space. So if you want to restrict for the aesthetic purpose or aesthetic appearance purpose or something, what you will do, you can restrict this depth, then what happens, even in the tension also developed here. And also it can be tie easily when you are providing the ties, stirrups, you can tie easily with this bar, so that there is a bond between steel and concrete will be more. So doubly reinforced sections are more preferable than singly reinforced section. But theoretically we will discuss the singly reinforced as well as doubly reinforced sections. So before we are going into the problem, now we will go with some Codal provisions. Very important, Codal provisions. Codal provisions. First one is minimum reinforcement. Please understand, in the RCC there is a lower limit and upper limit. In between only we will use, we do not less than, we do not cross more than. We will be within this lower limit and upper limit. Okay, so even in the problem, according to your problem, your reinforcement is less than the minimum also, you do not provide that whatever you are getting, you should provide minimum only. Sometimes you are crossing your limit maximum also, you don't want to cross your maximum, you should be restricted to, you should change the dimensions of the section and you should be restrict to maximum only. So how much the minimum amount of reinforcement you should provide? that is AST minimum divides with BD, width of the beam, and effective depth equals to 0.85 times divided by Fy. In 2003 gate, the minimum reinforcement provided in beams is AST minimum divided with BD equals to 0.85 divided by Fy. This is the minimum reinforcement. What about maximum reinforcement, sir? So the maximum reinforcement you should provide is AST maximum equals to 4% of gross cross-sectional area. So you should restrict up to 4%. Gross cross-sectional area is nothing but what? B into capital D. You calculate B into capital D, 4 divided by 100, then you will get the what is the maximum area of steel you should provide. Your value should be within these two limits. Every problem you will check it after getting area of steel, whether it is more than this and less than this. You have to cross check it. Next one is cover. Cover means, see, whenever you are seeing beam or column, you can't able to see the reinforcement because you are providing some cover. Sir, how much cover you should provide? For beams, cover should be, that is C, 25 mm. The minimum cover you should provide is 25 mm, not less than this. You should be use more than this also. 30 mm, 40 mm, 50 mm you can use it, but 20 mm you should not use. Minimum is 25 mm. Why we are providing cover? You should not, reinforcement should not be exposed to the atmosphere, so that what happen? There is a corrosion will develop, weathering. So the minimum cover for what is that beams is 25 mm. Next one is minimum dia of bar. Minimum dia of longitudinal bar means main bar. In the beam you will use main bars. The minimum dia of bar you should use is, we denote with the dia this symbol, that is 12 mm. For example, you are going to use 10 mm. No, code will not accept. Minimum 12 mm you should use. You can go for 16, 20, 25 according to requirement, but 10 mm no, minimum should be 12 mm. Okay, so please keep in all these codal provisions and everything. It is very, very useful for the coming problems. So if any doubt you can ask me. So thank you.